Hello everyone, my name is Anthony Shivkumar, and in today's video I want to talk about or basically build the breakout board for these 9-axis I.M.U by CEVA. It's called the FSM300, and this is the board that you buy, and I want to create a breakout board so that we can use it and connect it to a microcontroller. So what I have over here is the FSM 3000. So I'm just going to zoom in a little bit over here. So this is the FSM300, the I.M.U module, and let's open it and see how we can go about designing the breakout board. This is by CEVA, however you pronounce it, the FSM300, and I am going to basically, this is it. I'm just gonna let's zoom in a little bit and get the board over here. So this is the FSM 300 by CEVA, and what we want to do is create a breakout board so that we can basically solder these pins and start to use them, because I can't really solder any through hole thing onto it. So let's have a look over here. So I can't really solder anything onto it. It does tell me what the connections are, but I can't really use it directly. I can't even put on a breadboard. So we'll create a breakout board that can basically help us to solder these joints onto a board, so then we can take those pins and connect it to a microcontroller. Okay, so that's the topic. Let's take the dimensions over here. So I'm just going to take a simple ruler, nothing too fancy, and just to get a sense of what we're designing over here. This is approximately 2.5 centimeters. So that's 2.5 centimeters in length, and in width we are looking at approximately 2 centimeters, give or take. We look at the data sheet to get the right dimensions, but we're looking at 2.5 centimeters by 2 centimeters. So a breakout board should be slightly bigger than this. That will accommodate some other pins as well. They already have some things attached to it, but the data sheet will tell us how to use it properly. So let's go and look into the data sheet. So what I have over here is the FSM30, and that's what we basically have, the FSM module, which has got the VDD ground and RSVR. So when we look around over here, we have these three little things over here, 1, 2, 3, and maybe if I just rotate this a little bit. Okay, so they don't talk about this. So the three top pins on the top right from the data sheet is VDD, ground, and RSVR, and then we have 4, 5, 6, 7. So 1, 2, 3, 4, 5. So the 6 pins over here are these 6 pins, 1, 2, 3, 4, 5, 6, and that's the ground. So you can also see like the ground, which is the second pin, and the fourth pin is connected to this big polygon over here. You can see this, so that's all connected to the ground. So that should give a good sense that this is ground and this is ground. And on the right hand side we have all the CSI, MOC, SPI and I2C data connections. So let's go about and design this whole thing. So a description of each pin is listed in figure 2. For pins with internal pull-up, pull-down, the value of the pull-up resistor is 34 kilo ohm, and the value of the pull-down resistor is 6.2 kilo ohms. So that tells you what the pins are. And if we are wanting to connect it to the host, if we're using say an I2C host, then we would want to have like say 2.2 kilo ohms for 2.2 kilo ohms for the SDA and SCL, and So it'll give you this connection. So this is if you're using the I2C protocol. If you're using UART, this is how you want to connect it. And if you're using the, say, so this is UART, I think it's only receiving. So this is just one connection. Here we're looking at bidirectional if you want to control it. And here we're looking at SPI. So if it's an SPI host, it'll be a little, the connections will be a little different. So we got to choose which protocol we want. So if we're using SPI, if we're using UART, or if we're using UART RVC, we don't have to have any other external components. If we're using I2C, then we have to use the 2.2 kilo ohms, which is an additional component that we got to buy. So let's try to keep it simple, save on cost, and try to create something as simple as this, like literally just connect the wires, and we should be good to go. So that's what our aim is. Now I do have Altium open up over here. Now what I haven't been able to find is a footprint of this board. So what we're going to do is we're going to create this footprint, and from this we will try to so we have to create this footprint board, and then we'll have to create these dimensions in Altium, and then from here we'll do the connection. So it's going to be a little long video, and you can follow with me if you want to create a breakout board for this particular I.M.U. So we'll start off with the pins, and what we'll do is go right on top, and it tells you what we want. So I'm going to go to Altium, and I'm just basically going to create a simple block. And I haven't used this feature in a while, to be honest. I normally just go and so we have the CEVA FSM. I need to draw a basically where is the thing? Yeah, so let's take a rectangle, and I'm just gonna put something like this in here. Yeah, something simple. Put this in here, put this in here, and this will be the pin. And what do we have over here? We have 1, 2, 3, and 9. So let's try to, I'm just gonna basically one, 2, 3, and then we'll have the other 6 over here. 1, 2, 3, 4, 5, 6, something of this sort. And we can take this pin, copy this, and paste this over here. Okay, and on the right it'll give you all the properties of what we want. So it's going to be a line, solid state line. Yeah, this is the if how you want to style a line. If I'm not mistaken, oh okay, so how do you create pins? Nope, that's not what we want. Yeah, we don't want part A, part B, part B, part C. Okay, I'm just made a small little mistake over here, so I'm just going to delete all of this, because we definitely don't have part A, part B, part C in here. So I'm just going to draw the rectangle again. Doesn't matter because we haven't done much anyways. And then I just want to place so if we place something like this, then these. So we have, just gonna put this symbol on here. So it's gonna be and then we should be able to just gonna save this, and then we should be able to basically wait, I think I'm okay. Oh, here we go. That's what my mistake was. So yeah, so we can basically okay, that's what we want to do. There's a place bin. We take these guys, move it in here, we stay in here. We'll use the data sheet to do this. We can have VDD, ground, and RSVR. So we'll want to have this as VDD. Just gonna save this, and yeah, and then actually it'll be the other way around. Put this as bin 1, and this is gonna be VDD. Okay, yeah, something like that, and then we can put the line so that you know you can have the connections to it. So this will be 1. I'm just gonna do an alt, and this is gonna be ground and RSVR. So this is gonna be ground. Designator is gonna be 2, and this is gonna be RSVR, and this is gonna be 3, and I can draw the line, something of that sort. Cool. And here we have RSVR again. I don't know what RSVR is, we'll figure that out shortly. So we have RSVR, and this is gonna be pin 4. Remove this, and yeah, this is what I'm basically copying this over here. H int n, H I N T n, and this is going to be 4 5. Okay, and then we have boot n, and this is going to be 6. PS1, that's going to be 7, and ground. And then this is going to be PS0 walk-in. Yeah, something like that. PS0 waken, walk-in, waken. Yeah, something like this. Can even make this a little bigger. Yeah. Yeah. Maybe even move this slightly. Something like that. Okay, and then draw the lines. Okay, cool. And the next part is an RSD, RSVR, RSVR. So this is 9. Oh, so it goes 10, 11, 12. Okay, so we basically have to do the same here. So what I'm going to do is, so it's going to be 1, 2, 3, 4, 5, 6, and then we have here 1, 2, 3. Okay. RSVR. But I'm going to basically put X to this, yeah. So I'll have to basically, we don't need any of this, and then something like that. Just flipped it around, and then STA MISO TXT. Okay, MISO TXT. Okay, SCL SEK RXT. So this is 9, this is 10, this is 11, and then here we have SCL SEK RXT. SCL SEK RXT. So you're basically using both the protocols, which is the I2C and the SPI. Just gonna make this slightly bigger. Move that somewhere around here, which might be, yeah. Okay, something like that. Something like that. Something like that, maybe. Ah. Yes. Anyways, I think it's clean enough. And then we have the 13th one is going to be RSVR. And then we have SAO MOSI. So SAO is probably for the I2C. Allows you to set the address. And for SPI, it's master and slave out. Oh, so MOSI, that's definitely different from SI. Then we have CSN, should be the this chip select, generally for SPI. And here we have RSVR, RSVR, and NRSD. Can I do this? Oh, maybe, yeah. SVR. And then we have NRSD. Yep, something like that. C Control V. something like that, yeah. So we do have this as the I'm just looking at it from there it is. I don't know what I can put the line in here. If I put the line, so this is a line, but is there a track that I can put? Just wondering. Yep, my daughter is crying at the background. So sorry for the baby noise. Yeah, how do you elongate it? So in here, what they done? So that's VDD and placement, package delay. Okay, so this is what they've done. Okay, so maybe if I go in here, yeah, I might have to like remove all these lines. Just remove all these lines and remove all these lines. But no, I wanna. Okay, so the lines are interesting. Okay, so I'm just going to do one of them at a time. Yeah, I think they're overlapping. Might do a two-part series, so I'm just going to basically finish this, then we'll do the PCB the next time around, and then that's going to be a slightly long. And here what I can do is, this is the pin length, and I think if I just do this, yeah, perfect. So what I'm going to do is do something like that and make sure all the pin lengths, come on, one, and yeah, and we'll put this as perfect. And then what I'll do is, to keep things slightly clean, to go to view, set grid, and here instead of 2.54, I'm just going to put this as 0.1 mm, 0.175 mm, or 0.254, 0.254 mm, something like that. And just align it so that it looks nice and clean. And yeah, so that looks good. Perfect. So now that we have this, we have to now create a footprint for this. So this is how the thing would look like over here. So I've just already created a small little thing over here. So if I go in and use the I.M.U sensors over here, I do already have the CEVA, and it'll look like this. So it's looking good. Perfect. So that looks good. So let's now create the footprint. The footprint is going to be very tricky. Yeah, I definitely do have my baby screaming at the back. The mic that I have does not filter out the background noise as much as I would like. I don't have such a device yet, so hopefully it's not too annoying. What we'll do is I will basically open a new schematic. So what I've basically done, just to get a sense of how I I've organized my, I'm still working on cleaning it up basically for all the components. I'm just going to open this up over here. So these are all my components, and I've placed them as adapters, ADC, breakout boards, cameras, and here we have the sensors, and under sensors we have the I.M.U, and in the under the I.M.Us I have my my different I.M.U sensors basically. So in here I'll probably be creating the CEVA and it's called FSM300. So in here I'm going to create the footprints. I'm going to create a file, new library. It's going to be, I guess it's going to be a PCB library, and there we go. And on the left hand side you should have basically what the library is, and here I'm just going to put here as the, what is this footprint called? So if I go here, and the footprint dimensions and for us to create the footprint will be at the end of the data sheet, and here it is. This is what we need. This is an 18-pin PCB module, so I'm just going to call it the FSM300. So in here I'm just going to put this as CEVA FSM300, something like that. And what is the height and area? In this is going to be in inches, so we can get this dimension right from here. It's going to be 25. Is this in, so here we go, 20 mm by 25 mm. That's exactly what we measured. Units are in millimeters, so 20 mm. So length is going to be 25, height is going to be 25 mm, and area is going to be 25 into 2 is going to be 50, so it's going to be 500 mm. So I'm just going to put just 500 mm, and then let's click OK. Okay, I don't know what it did, but and now we'll start to draw. So I'm just going to create a fill of something like actually, so when it comes to this here, it's going to be a little tricky because oh yeah, I would just save this. This is the PCB lib. So wait a minute, didn't we? Okay, save PCB. Let's now. So I'll go to my. It's gonna be in shift. It's gonna be in components. Altium components under sensors. So we have sensors. This is gonna be an I.M.U, and under I.M.U we put the CEVA, and the other is gonna be I.M.U. Actually, I should put under I.M.U. Yeah, I'll just probably put this as under I.M.U. I.M.U. and sensors. Yeah, just put that over here, and then this will be the CEVA. Okay, and what we want to do is this would be in the, I'll put top overlay. So for example, say we've got this one, which is the I.M.U BH160, which is going to be here, and we've put the 2D, so the paths are something of this sort. So we'll create the outline first, and what I'll do is just going to click at the it's got to be something that tells me how to create the outlay. Won't be keyboard area for sure, it'll be the I'm just going to open one of the footprints. So I'm just going to let's go to the BH160, and in here I'm just going to open the PCB, So yeah, and this one, this green one, is on mechanical 15. So what I'm going to do is go to my sensor. Oh yeah, it's going to be in here, and then I'm going to go to mechanical 15. Mechanical layers, we can even do the mechanical one, and let's now create a line. So this is going to be, we're just going to put this as edit, set, view grid, and I'm going to put this as 5 mm. So, and then I'm going to basically draw the line. So it's going to be 1. Okay, so there we go. 5, 10, 15, 20. No, it'll be like 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. And 5, 10. I mean, yeah, this should be the outer layer of the board in some shape or form. It's a mechanical one basically. And if I go in here, and then here we create the pads. So this is going to be, okay, so they have mechanical one this way, and then let me just basically try to eliminate this. The video is already half an hour long approximately, or it's getting there at least. So I will be continuing to work on this in the next video, and until next time, it'll be around sometime tomorrow. I should be able to continue on this, and yeah, it'll be a follow through on this. So I'll work on this for another 10-15 minutes, because I'm mostly doing all live streams at this point in time, and so I'm gonna be slightly interrupted, but let's try to finish this, and then we'll go. Okay, so let's open the layer, and I'm going to remove the thing, and then here you have, this is top layer, and what do we have over here? And that's the top solder. Okay, so this should be in here, and what we're going to do is cancel this, and I'm just going to click on place, yeah, place, yeah, you know, place, place pad. This is what we do. Okay, this is the pad. No, that's not exactly what we want. Place. We are a 3D. No. Keep out. Mentions. Wanna know what we can do here? Polygon. Interesting. So yeah, I haven't done this in a while. I've completely forgotten. So yeah, this is the top layer. This over here is the top solder mask. So we got here as the so we have top solder, and then here we have this top solder. So we have here, and here we have descriptor 2. It's 2, and like that. So if I just go in here and then go to here, I don't think we can do that. So yeah, it's been 35 minutes. I gotta go, and we'll continue this tomorrow. Thank you so much.